But let's talk about, just briefly, the other algorithms we're going to learn. Then we'll demonstrate all of them. Maybe easier that way anyway. So k-nearest neighbors, we talked about how we figure out the k closest records to the one we want to know about. And we use the majority of those records, what value they have in the response or the result or objective that we're trying to figure out. Another data mining algorithm is known as the classification and regression tree algorithm. Okay. And the way that works is it actually says, let's go back to our example of the credit application, and let's say what we find as a pattern in the data is if we would divide the data based on just one field alone. Let's say, for example, we find that that data is the duration of the loan, how long they want to take to pay back the loan. And we find that if we take the data and divide it into two categories from that is the durations that are less than 12 months and the data that is for 12 months or more, that does a fairly good job of dividing the records into those that get credit and those that don't get credit. Okay? So we may find, for example, that of those with a duration of less than 12%, that something like 75% of those successfully get a loan. Whereas those who are greater than 25%, only 25% get a loan. Okay? And so that's a good way that divides the data into those that get a loan and don't. But it's not perfect. And so we may further find that there's another way we can divide this part of the data for durations of less than 12 months, okay, to divide into two more categories, which do a good job of dividing it into those who maybe don't get loans and those who don't or do. So for those of a duration asking for a loan for less than 12 months, maybe the next thing that matters is the amount of the loan. Okay? And we find that those who want a loan for less than 12 months for greater than, $5,000, they don't get a loan very often. Whereas those who want a loan for less than $5,000, still for a duration of less than 12 months, maybe they do get a loan, much more often than not. And maybe the percentages are even better. So at this point, we've divided it down to 90% of the people who get a loan for less than 12 months for less than $5,000 will give a loan to them. Okay? Those who want a loan for less than 12 months but for more than $5,000, okay, maybe it's a much smaller percentage of those that get a loan. Okay? So maybe only 20% of them get a loan. So you can see how we're trying to take the data and divide it into different categories. Now maybe those that want a loan for more than 12 months, most of those don't get a loan, right? Only 25% do. Maybe we find that there's another field or another attribute of those records that can further subdivide them into those that get loans and those that don't get loans. Okay? And I don't know what that would be. Maybe it would be for the type of loan or what they want to use the money to do, whether they're buying furniture or cars or something like that. And that divides the records in those 25% of records that do get a loan. We can maybe put most of them on one branch, and the 75% that don't get a loan would fall under this branch. So we've divided the data again better. And we can keep going and keep going, okay? Further and further dividing the data. We call this a tree because it kind of takes the data and sort of like a tree would. It sort of starts at the top and then gets wider and wider the further you go down as we divide the records into more and more subcategories and subcategories and so forth. Okay? And in the end, you get down to some amount of records, those that, in this case, would get a loan, let's say, and those that wouldn't get a loan. And then these maybe you divide it into those that get a loan and those that don't. But you want to see that the group, the size of those two groups are very different. at the bottom of the tree. You want to have divided the data down so that you say most all the records that follow that path or that pattern either do get a loan or don't get a loan, depending on what you're looking for. Okay? That's a classification and regression tree. Now, before we move on, I want to address what's meant by these terms classification and regression, because it's somewhat important. If you'll remember back to last week, when we talked about databases in Excel, we talked about the different types of data. We said there were two types of data. There was categorical data, and there was numeric data. Okay? And we said categorical data was things like, you can say, gender, things like, in this case, type of loan, so what the loan was being used for, anything that you can just break into different categories. Okay? And numeric data simply was just anything that you can numerically represent. So age, in the case that we had here, number of months of a duration for a loan, those things are all numbers. Things you can add, subtract, use various mathematical operators on. If we're trying to divide records up for the purpose of categorizing them, that is, we're trying to predict a categorical value, we call that classification. Okay? So classification involves categorical data. If we're trying to predict or find a numeric value, that is, we're going to have to numerically compute things like average or median or other numeric results, we generally call that prediction. Now, that's an unfortunate term. It's one utilized in the textbook and other literature, because really, we're trying to predict a value either way. It's just whether or not we're trying to get a categorical result or a numeric result. And when we have an algorithm trying to get a numeric result, we refer to that as prediction. We refer to getting a categorical result as classification. We're classifying records into different categories. Okay? The k-nearest neighbor algorithm is actually very good at doing both of these. Okay? Can be used to do both. For instance, when we were looking at the example I had up here with just the colored X's, those were categories. They were just colors. There was no number involved with that. It was just a color, red, green, and blue. On the other hand, we might use k-nearest neighbor, and we could use k-nearest neighbors to find a categorical result by just measuring the k closest records, what category are they in? And that's the category we'll predict. If you're wanting to use k-nearest neighbors to compute a numeric result, all you do is you take a look at the k closest records and compute, say, the average numeric value of all those. So if I was trying to predict, for whatever reason, the age of people based on some record data, and I used k-nearest neighbors, then I would look at the k closest, most similar records, and I would look at their ages. So maybe the k is 4. I would look at the 4 closest records and average their age to predict the age of the record I'm wanting to know about. Does that make sense? So k-nearest neighbors can do both classification and prediction. Classification trees can also do both classification and prediction. So in the example we're using of credit, that's a categorical type of value. Whether or not you give somebody credit is just a category. It's a yes or no, true or false, credit or no credit. It's just a category, okay? And we could use classification trees to subdivide records into those who get credit and those who don't, and then say for new records, we'll just take whatever path through the tree that represents the pattern of that data and see whether most of those records get credit or not, and that's the categorical result, okay? Classification trees can also be used for prediction in much the same way that k-nearest neighbors is, in that you take a new record, you follow the path through the tree that represents what that record would do, and then you look at all the values from the training set that followed that same pattern, and you average their numeric values if we're predicting age or some other numeric number, you just average their values, and that becomes your predicted number. Okay? So k-nearest neighbor and classification trees can handle both categorical and numeric data. That is, they can classify records, they can predict records. Okay? There is one specific difference, though. The k-nearest neighbor algorithm can only use numeric data as the fields in the records. Okay? Remember, k-nearest neighbor relies on figuring out how different two records are so that it can figure out what the k most similar records are to a record you're wanting to predict or classify. But in order to compute difference, it needs numbers so that it can take one number minus the other to figure out that difference. Okay? So k-nearest neighbor relies on having numeric data. Classification regression tree algorithm can use both categorical and numeric data, either one. Because all it's doing is finding, for all records, how do I divide those records into two parts? And if it's categorical data, you just divide them based on their categorical. So gender, you would divide it into males and females. If it's type of loan, you might divide it into those that want a car, trying to get a car with their loan, and those who don't. Okay? Anything can be divided into two categories if it's categorical. Likewise, anything that has a number can be divided into two categories. Values greater than and values less than a certain number. Okay? So k-nearest neighbor can predict numeric results, they can classify categorical results, but you have to have all numeric data in order to compute differences. Okay? Classification trees can do classification and prediction, and they can use both types of data interchangeably. Some of your data can be one type, some of the other type. It wouldn't matter. Okay? All right. The last algorithm we're going to learn tonight is known as multiple linear regression. And multiple linear regression looks like this. If there's some output value, some value I'm going to want to predict, say y, and there are some fields of data, let's call it x1, x2, and so forth, up to xn, okay? Then multiple linear regression just says there is some mathematical formula that I can multiply some value m1 times the value of field x1 and add to that some number m2 multiplied by the value in field x2 and so on up to all n fields and sum all that up, and that will be my prediction, or that will be the value of the model for that record. Okay? So multiple linear regression is just linear multiplications of some number by the value in each field, and then summed up as the model value, the value we're going to predict. Okay? And so, as you might expect, multiple linear regression can only use numeric data, because it's going to multiply values here. Can't multiply a number by a category. So it only uses numeric data, and it can really only predict numeric data. The whole model, multiple linear regression, is just literally a mathematical function. Okay? K-nearest neighbors, no real math involved except differences between two records, differences between values. Classification and regression trees, no math at all, right? We're just comparing records that fall in one category or another, or values greater than a certain value and less than that value. Multiple linear regression is very mathematical, okay? So three very different algorithms, okay, all of which can be used for some of the different purposes we have. Classifying records, that is finding a categorical result, or prediction, finding a numeric result. Some of them can use different numeric and categorical data. Some of them can only use numeric data. Okay? If you'll remember last week, when we talked about numeric and categorical, We also talked about how you could convert data from one type to the other. Okay? For example, if I had a database and I wanted to use multiple linear regression as a data mining algorithm on that data, if I had any data in that database that's not numeric, I would have to convert it to be numeric for multiple linear regression to work. Everything has to be numeric. Okay? And we talked about how to do that last week. There are other data mining algorithms, some of which can be used for classification, some prediction, some both. And some of them have similar restrictions on whether or not they can use only categorical data, numeric data, or both. Okay? But these are the three we'll specifically look at in this class. Okay? Any questions about that?